Practice Test 3 for Test 3, Chapter 7, Confidence Intervals. This particular practice test only deals with sections 7.1, 7.2, and 7.3. Unfortunately, it does not cover section 7.4 with the chi-square intervals for true population variance and standard deviation, but I will cover an additional problem at the end of this lecture so that you can see another example from section 7.4. So let's begin. As I cover each problem, I am going to tell you where the problem can be located. Which one of the following sample statistics is an appropriate point estimate of a population mean? The answer is X bar. Remember, X bar is the point estimate for true population mean mu, X bar. That's the sample statistic or the point estimator that's used to estimate population mean. That is from section 7.1. Number 2. In computing a confidence interval for a population mean, when should you use the standard normal distribution instead of the student t distribution? You should use the standard normal distribution in Z when sigma is known or n is at least 30. If we read all of these, n is small, n is large, n is large, n is large. N is large means that n is at least 30. The answer is D. Use a Z interval instead of a T when sigma is large, greater than or equal to 30, or sigma is known, population standard deviation is known. So when I say large sample size, N, it implies that your sample size is at least 30, greater than or equal to 30. First two questions, either you know it or you do not know it. And you move on to the other problems. Number 3, find the critical value for an 80% confidence interval when using the Z table. In other words, you are working with a Z interval for the mean. I will go through the procedure and show you how to use the Z table. And this is question number 3. Remember, you take the standard normal distribution in Z, the mean is 0, and you would bound the middle 80%, 0.80. This area is 0.4000, and this area is 0.4000. Together, that's 80%. Since the total area under the standard normal curve is 100% or 1, and we already have 80% covered, that means we have 20% more area in both tails combined. So each tail would be 10%. So 0.1000, 0.1000. We're looking for the negative Z and the positive Z that bound the middle 80% of the standard normal distribution. You would look up in the Z table, the area below negative Z is the 10%, and the area below positive Z would be 90%. If the area above it is 10%, then the area below it is 90%. Going to the Z table, in class, I stressed that you would really only need to find one of these Z's, and the easiest one would be the negative Z. The closest area to 0.100 or 10% would be here in the 2-page Z table. Work your way out to the negative 1.23 and work your way up to negative 0.08. And that gives you a Z-score of negative 1.28. So the closest area to 10% in the table is 0.1003. Work out to a Z-score of negative 1.28. To look up the 90%, the closest area to 90% is going to be 0.8997. Again, work out to 1.2 and up to 0.08, so it is 1.28 for your z-score. Plus and minus 1.28 will be the z-scores that bound the middle 80%. Question number 3. The answer will be negative 1.28 and positive 1.28. Therefore, if you ever have an 80% confidence interval for the mean, and we know that it's a z interval, not a t but a z, z sub c is 1.28. If it is an 80% confidence interval for true proportion, that is still a type of z interval. Z sub c is 1.28. On the calculator, you would not need the picture. You would do 0.8 divided by 2 is 0.4. 0.5 minus 0.4 is the area below the unknown negative z. So second variables, number 3, invert the norm. The area below the unknown negative z is 10%. Mu is 0, sigma is 1, and paste, because we are in the standard normal distribution. And to 2 places, the z-score is a negative 1.28. If you did invert the norm for that 90% area below the unknown positive z, you would have a positive 1.28. And that's the critical value. Always go with the positive. So z is 1.28. That is question number 3. On the test, I could give you a 96% z interval, a 97% z interval, 94% z interval, 92% z interval. So definitely know the procedure. Number 4. A sample of 14 cars on Front Street was traveling an average of 31 miles per hour with a sample standard deviation of 4.25. Assuming that the distribution of speeds is normal, find the 99% confidence interval for the true mean speed of all cars on Front Street. The information that is given is the sample of 14, that's your N, and these cars were traveling an average of 31 miles per hour. That's X bar, with a sample standard deviation, S, of 4.25. Assuming the distribution of speeds is normal, find the 99% confidence interval for the true mean speed. That means this problem is either a z interval for the mean or a t interval for the mean. It's actually a t interval for the mean, section 7.2. I'm going to write this information down. This is number 4. Again, the sample size is 14 cars, and they were traveling an average of 31 miles per hour with a sample standard deviation S of 4.25 miles per hour. And they ask us to find the 99% confidence interval for true mean. This is a t interval. Sigma is unknown, and at the very same time n is small, less than 30. Both conditions are satisfied. They don't give us sigma, but they give us S, sample standard deviation. Therefore, x bar minus t sub c, s over the square root of n, less than mu, x bar plus t sub c, s over the square root of n. That's going to be 31 minus t, 4.25 over the square root of 14. 31 plus t, 4.25 over the square root of 14. T. Going to the T table, we will go to row 13 and column 99%. So you will wish to get out the T table. Sample size is 14, so go to degrees of freedom. 14 minus 1 is row 13 and column 99%. Row 13, column 99%, your critical value T sub C is 3.012. 3.012. Row 13, column 99%. 3.012. And I will write that let's find E, 31 minus E, and 31 plus E, and round to 4 places accurately. 3.012 times 4.25 divided by the square root of 14. Enter. .4212 is your E. 3.4212 rounded to 4 places. I'm going to subtract that from 31, and I'm going to add that to 31. And those are your upper and lower numbers there for your confidence interval. Now I'm going to write those numbers down. So when you subtract, you get 27.5788. And when you add, you get 34.4212. This is where we round to the same number of places as the given sample mean, which is 31 as whole number. So 28 less than mu less than 34. Final answer. Going back to the sheet, that is answer A. Notice how I wrote down my critical value from the T table and my margin of error, because I can ask those as separate questions. And then your confidence interval width is 34 minus 28. And that difference is 6. So your confidence interval width would be 6. 34 minus 28 is a difference of 6. Going to the calculator, if you're just going to use the TI-84 to do this, you'll go to Stat and arrow over to Test and go down to number 8, T interval. Enter. This is statistical. The sample mean was 31, the sample standard deviation 4.25, sample size 14, and 99% degree of confidence. And calculate. It does pause for T intervals for some reason. And if you round a whole number, 28 to 34. Again, it would be 34 minus 28 as your confidence interval width. In case I went too quickly through that. 27.57834.422. Question number 5. Look at this. What is the maximum error of estimate for question 4 above? Round to the nearest 10 thousandths. 3.4212. There's nothing to show you here. I did use this formula to find E above. 3.4212 4212. So the answer is D. That would be the first page of lecture. Practice test 3. Next page. 6. A fast food company wants to determine the average number of times that a fast food user visits fast food restaurants per week. They want to be 95% sure that their estimate differs from the true mean number of visits by no more than 2/10 of a visit. Previous research has shown that the standard deviation of the population is 0.5, a half a visit. What is the required sample size? This is sample size for the mean. They do give degree of confidence to be 95, and they want their estimate to be, they want to be sure that their estimate differs from the true mean. So the estimate is x bar. It differs from the true mean mu by no more than 2/10. That's your E. Research has shown that the standard deviation of the population, sigma, is 5/10 of a visit. What is the sample size needed? This problem is from section 7.1, and you can see that I've written here that the given information is they want to be 95% confident that their estimate, x bar, differs from the true mean, mu, number of visits by no more than 2/10. So E is 0.2, and the population standard deviation is 0.5. The formula for sample size for the mean is going to be Z sub C times sigma over E quantity squared. Since it's 95%, we have memorized as a class several times the procedure using the 2-page Z table. If it's 95%, Z's 1.96 is a critical value. You would plug in 1.96 times 0.5 divided by 0.2 quantity squared. And that in the calculator looks like this. 1.96 times 0.5 divided by 0.2. 4.9 before you square it. And that's 4.9 quantity squared, which is 24.01. So your final answer for sample size should be 25. Always round up, regardless of decimal, to a whole number. Going back to number 6, I basically have written this off to the side. The answer is C, 25, even though you got 24.01. Question 7. A computer company wants to estimate the hours spent per week adults use computers at home. In a sample of 21 adults, the mean length of time a computer was used at home was 7.3 hours. From past studies, the company assumes the population standard deviation to be 0.8 of an hour. Construct the 95% confidence interval for the true mean. Let's pick out stuff. A random sample of 21, that's your N, showed that the mean length of time computer was used was 7.3. That's x bar, sample mean. From past studies, the company assumes population standard deviation sigma is 0.8 of an hour. Find the 95% confidence interval for the true mean. This is a Z interval found from section 7.1, and I'll write this down. This is number 7. N is equal to 21. X bar is equal to 7.3 hours, but population standard deviation is 0.8 of an hour. Just knowing sigma makes it a Z interval, population standard deviation. Construct the 95% confidence interval for the true mean. 95% confidence interval for the true mean. Now again, this is a Z interval because either sigma is known, which it is, or N is at least 30. N is not at least 30, but I don't really care. I only have to satisfy one, that sigma's known. And they do say population standard deviation is 0.8 of an hour. Once you identify this as a Z, it's x bar minus Z sigma over the square root of n less than mu less than x bar plus z, sigma over the square root of n. Since it's 95% confidence, z is 1.96. And we have everything we need to plug into the formula. 7.3 minus 1.96, 8/10 divided by the square root of 21. 7.3 plus 1.96 times sigma over the square root of n. Got a little messy there, I apologize. This is E, so 7.3 minus E and 7.3 plus E. That's going to be the 1.96 times, parentheses, 0.8 divided by the square root of 21. .96 times 0.8 over the square root of 21. 0.3422 is your E. So 7.3 minus 0.3422, lower number. 7.3 plus 0.3422, upper number. And I'll write these two numbers down. E is 0.3422. And my lower is 6.9578. And my upper is 7.6422. We round to the same number of places as the given sample mean, which is the nearest tenth. So this is 7.0 to 7.6. Final answer. The confidence interval width is only 6/10, which is 0.6. 7.6 minus 7.0 is a difference of 0.6, or 6/10. Going back to the question, the answer is B. And then question 8, give the maximum error of estimate to 4 places in this problem above, and that E was 0.3422, and that answers D. And then I said give the critical value for problem 7 above, and since it was a Z interval and it was 95% confidence, we know that that answers A. So 7, 8, and 9 all are tied together. 7, 8, 9, Z interval. For this same problem, you could put this problem into the calculator. Stat and test. Arrow down to 7. Sigma is 0.8. X bar is 7.3. Sample size is 21. And C level is 0.95. Calculate. If you round to the nearest tenth, you get 7.0 to 7.6, which is the same answer we got by hand. But this would be a Z interval for the mean. Question 10. The SAT scores for 5 randomly selected high school students are listed. Find the sample mean and sample standard deviation. Round the sample standard deviation to 1 decimal place. And that's because these are whole numbers. So according to Chapter 3, if we have to round the sample mean and sample standard deviation, it would be to the nearest tenth. Finally, construct the 98% confidence interval for the true mean. Now this is a T interval, and the main reason is N is only 5, very small sample, so it's less than 30, and at the very same time, they never mention population standard deviation. As a matter of fact, we have to find sample standard deviation. So sigma is unknown, and at the very same time, N is small, it's less than 30. To find the sample mean, this is what I would do. I would go to Stat, Arrow, well, no, under Edit. And I'm going to use L3 and put in these values. 1424, 1223, 987, 829, and 937. stat, calculate, one variable statistics, and I got to change it to L3, and then calculate. The sample mean is 1080, exactly, nice. And then the sample standard deviation S is 240.3. 240.3. As a reminder, if you don't have a TI-84 calculator, you are going to have to make a X column 1424, 1223, 987, 829, and 937, and then you're going to have to square each of them. And I can use my calculator to tell you the summation of the x's is 5400, and the summation of the x squared column should give you 6062884. 6,062,884. So let me show you that. Therefore, sample mean is the summation of the x column divided by n. So 5400 divided by 5 is 1080. And then variance is the summation of the x squared column minus bracket, summation of x column quantity squared divided by n, all divided by n minus 1. On the calculator, I'll show you this so that you can have standard deviation. 6,062,884 is the summation of the x squared column minus bracket. The 5400 quantity squared is the summation of the x column quantity squared divided by 5, and then enter. There's your numerator. So summation of x squared minus the summation of the x column quantity squared divided by 5, all divided by 4. There's your variance. But the standard deviation is the square root of variance, so I take square root of second answer. 240.3 is S, sample standard deviation, 240.3. So this would look like 6,062,884 minus 5,400 quantity squared divided by 5, all divided by 4. And that variance was 57,721. And then S is the square root of that, 57,721. And we get 240.2519511, which is 240.3. Sample standard deviation. This is if you don't have a TI-84 calculator. I did not square each x, but I did give you the total if you do that, for the sake of time. Hopefully you have a TI-84 calculator and you don't have to do all of this on your test, but you should have enough time to do this on the test if you have to. But this is way back in Chapter 3. Let's go back to the problem. Once we find the sample mean for these SAT scores and the sample standard deviation, they wish for us to find the 98% confidence interval for the true mean. So basically, they give us raw data, and this is number 10. And we found the sample mean is 1080, sample standard deviation is 240.3. And they want us to find the 98% confidence interval for the true mean. And this is a T interval. Sigma is unknown. They don't mention population standard deviation anywhere in the paragraph. And they tell you to find S. And at the very same time, n is only 5, so it's definitely less than 30. Both conditions are satisfied. X bar minus t, S over the square root of n, and x bar plus t, s over the square root of n. You will have to go to row 4, because n is 5, degrees of freedom would be 4, and column 98%. Where your two fingers meet, that's going to be your critical value. Row 4, column 98%. Your two fingers meet at 3.747 for your critical value. 3.747. Row 4, column 98%. 3.747. So I'll write that down. 3.747. 240.3 over the square root of 5. That's your E. And that's subtracted from 1,080. And then 1,080 plus 3.747 times 240.3 over the square root of 5. The next question would be E. 3.747 times 240.3 divided by the square root of 5. Enter. Looks like 402.6730. 402.6730 is your E. So I'll write that down. 1,080 minus 402.6730 and 1,080 plus 402.6730. You will subtract from and add to, so 1,080 minus 402.6730 is the lower, and 1,080 plus 402.6730 is the upper number. And I'll write both of these down as well. Lower is 677.327 and upper is 1482.673. Round to a whole number because our sample mean is 1080 and it's whole. Final answer, 677 on the SAT to 1,483 on the SAT is our 98% confidence interval. And this was a T interval. And that is answer B. Answer B. I will not put this one in the calculator because we've already covered a T interval several times and I just did it above with this practice test. But that's how you do it by hand. I will probably ask you for E by itself and T by itself. So let's look and see if I do that. Can't remember. Number 11. Yeah. What is the critical value for problem 10 above? Notice how I don't say T. You have to know if it's T or Z. And it's a T because it's a T interval and it's 3.747. What is the maximum error of estimate or the margin of error for problem 10 above? And it was 402.6730. And for problem 10 above, what is the confidence interval width? That's pretty simple. You just take your confidence interval that we found in number 10 and say the lower minus the upper. And that was going to be 1483 minus 677. So there's the width. 1483 minus 677 is a confidence interval width of 806. And that answers A. Here we go. Suppose that 40 people were checked for anthrax exposure and the results stated the following. 8 people were exposed and 32 people were not exposed. Find the 94% confidence interval for a true proportion of people who have been told that they have been exposed to anthrax. This is kind of like a raw data problem for true population proportion. And this is a confidence interval for true proportion, and it's a 94% confidence interval for true proportion. And they talk about 40 people were checked for anthrax. That's your N. 8 people were exposed. That's your X. 32 were not exposed. 8 plus 32 is 40. All I care about is the 8 that were exposed. That's your X, because it's a 94% confidence interval for the true proportion of people who have been told that they have been exposed. So this is about exposure. This is not about those not exposed, but those that have been exposed. So let me write this down. N is equal to 40, and X is equal to 8. Find the 94% confidence interval for true proportion of people who have been exposed to anthrax. And I'm going to write that down. This is about those exposed. And that was 8 out of 40 exposed. Let's find that. That's going to be p hat minus z, square root of p hat times q hat divided by n, less than p hat plus z, square root of p hat times q hat divided by n. Since it is a 94% confidence interval and it's a type of z interval, you would have to find the z sub c by taking the middle 94%, 0.94, and that area divided by 2 is 0.47, and the area in each tail is 0.03. So with the z-table, you would look up an area of 0.03 here, and then an area of 0.97 here. Either 3% or 90% area below the plus and minus z. I will just look up the area of 3%. And the closest area to 3% is, where are we? 0.03. It looks like here. 0.0301 is the area below that negative z-score. Work your way out to a negative 1.8 and up to a positive, up to a negative 0.08. So that's a negative 1.88. Plus and minus 1.88 would be your z-scores. If you look up 97%, the area below the positive z-score, the area closest to 97% is 0.9699. Work your way out to 1.8 and up to 0.08. So the z-score is a positive 1.88. Therefore, 1.88 is the critical value for this problem. So z sub c is 1.88. P hat is x over n, or 8 out of 40. And that reduces to 1/5, which is 2/10 or 20%. Therefore, q hat is 1 minus p hat. 1 minus 20% is 80%. If p hat is 20%, then q hat is 80%. Plugging into the formula, that's the 20% minus the 1.88, square root of 0.2 times 0.8 divided by 40. And then 0.2 plus 1.88, square root of 0.2 times 0.8 divided by 40. 0.2 minus e and 0.2 plus e. And I'll put e into the calculator. .88 times the square root of parentheses, 0.2 times 0.8, close parentheses, divided by 40. Jump out of that radical and press enter. .1189 to 4 places. You would say 0.2 minus 0.1189 and 0.2 plus 0.1189. lower and upper number. And I'll write those down. 0.1189, 0.1189. Here we get 0.0811, and here we get 0.3189. Round to 3 places because it is proportion, 0.081 and 0.319. There's your final answer. According to the problem, that's A. 0.081 to 0.319. What is the maximum error of estimate or the margin of error? We found it to be E, 0.1189. What's the critical value? That's the Z sub C that we found for the 94% confidence interval. It was a positive 1.88. Look, 14, 15, and 16 are all tied together. I asked for the final answer, the E, and the critical value Z. All the parts. I could also ask for confidence interval width. You will go to stat and test and then down to alpha A. And you will say enter on one prop Z interval. The X is 8 exposed out of 40 tested, and 0.94 is your degree of confidence. Calculate. Final answer 0.081 to 0.319. Same answer as by hand. Question 17. And I'm just going to show you what I have written here for the sake of time. A researcher wishes to be 95% confident that her estimate of true proportion of people who travel overseas is within 5%, 0.05, of true proportion. Find the sample size N if a study prior to this study showed that out of a sample of 100 people, 60 traveled overseas. I will tell you that this is a sample size question for proportion, and we want to be 95% confident that her estimate, which is P hat, of true proportion P is within 0.05. That's your E of true proportion. Find sample size N if in another study it showed that out of 100 people, 60 traveled overseas. They are giving you P hat here. So the given information, 95% confident that her estimate, P hat, of true proportion of people who travel overseas is within 0.05. Find the sample size needed. If in a recent study or prior study, when N was 100, X is 60, and we have to find the sample size. Again, this is finding P hat from a recent study. 60 over 100 is 0.6. So therefore Q hat is 0.4. 60% and 40%. And my Z would be 1.96. The formula for sample size for proportion is N equals the P hat from a recent study times the Q hat times the Z over E quantity squared. This will be 0.6 times 0.4 times 1.96 divided by 0.05 quantity squared. And I will plug that into the calculator. 0.4 times 0.6, or 0.6 times 0.4, times 1.96 divided by 0.05 quantity squared. The answer is 368.7936, and that will round to 369. Final answer. Since it is sample size, we round up regardless of decimal. This is an easy decimal to round to because it is 0.7936, so it's 369. Final answer. And I have most of that written here, so the answer is A. Answer is A. Final question. Which of the following properties is not true about the student t-distribution? The curve is bell-shaped. That's true. Its variance is greater than 1. That's true. It is symmetrical about the mean. That's true. Its mean is non-zero. That's false. its mean is 0. So B is not true. Again, 7.4 was not represented, so I thought I would show you the worksheet. Problem number 4. I'm not going to show you all of these, but I will tell you the answer to number 1, worksheet, total assessment, is C, and it was a T interval, raw data, T interval for the mean from section 7.2, answer C. Question number 2 is a proportion Z interval for true population proportion, and it's 94%. So the critical value, the Z critical value is 1.88. The answer is D. So 1 is C and 2 is D. And this problem was from 7.3. Number 3, this is a Z interval for the mean, and the answer is A. It's coming from section 7.1. So 1 is C, 2 is D, and 3 is A. Number 4 is the one I do want to show you. And we're going to read it together and go over it. But the answer is C, and that's from section 7.4. The refractive indices of 15 pieces of glass randomly selected from a large lot purchased by an optical firm have a standard deviation of 0.012. Assume that these measurements can be looked upon as a sample from a normal population. Construct the 95% confidence interval for the true population standard deviation. This confidence interval is for true population standard deviation, so it is a chi-square interval. And let me write down the other information. We take a sample of 15 pieces of glass, and it was calculated that this sample of 15 has a standard deviation of 0.012. That's S, the sample standard deviation coming from the sample of 15 pieces of glass. So I'm going to write this down. N is 15, and the sample standard deviation is 0.012. And they wish for us to find the 95% confidence interval for true population standard deviation, and that's sigma. And that's really all the information they give. This will be n minus 1 times s squared divided by chi-square from the right, and you will take the square root of all of that. And then the square root of n minus 1 times s squared divided by chi-square from the left. The hardest part is finding chi-square from the right and chi-square from the left. So let's work on that. Again, the sample size is 15, and it was found that they have a standard deviation of 0.012. Construct the 95% confidence interval for true population standard deviation. You would draw the chi-square distribution. Remember, it starts at 0 and it's right skewed or positively skewed. It goes from 0 to positive infinity. And you want to designate a chi-square from the left and shade that left tail, and a chi-square from the right and shade the right tail. The area in the middle is 0.95, or 1 minus alpha. Alpha is 1 minus my 95% degree of confidence, which is 5%. So it works both ways. 1 minus degree of confidence is alpha, and that's 5%, and 1 minus alpha is my degree of confidence. That means in the two tails combined, I've got 5% left over. So this tail is alpha over 2, and this tail is alpha over 2. 0.05 divided by 2 is 0.025 in each tail. Remember how the chi-square table works. You have to go to row 14, degrees of freedom, and for chi-square from the right, the column you would go to is 0.025, which is the area above it. And chi-square from the left, the area above it is 0.975. So area above chi-square from the right, that's your column. Total area above chi-square from the left is 0.95 plus 0.025, which is 0.975. Here are your two columns. Row 14 and column 0.025 gives a chi-square from the right of 26.119. And then column 0.975 and row 14 gives chi-square from the left 5.629. Those are your two values. Row 14, column 0.025, and column 0.975. This is chi-square from the left, and this one is chi-square from the right. Let's write this into the formula. Going back to the formula above, I'll just block out the picture. This would be the square root of 15 minus 1 times 0.012 quantity square, because S was 0.012. Chi-square from the right was 26.119. And then the upper number is 15 minus 1 times S squared divided by chi-square from the left. And chi-square from the left is always smaller than chi-square from the right, and that was 5.629 chi-square from the left. And then calculate. What I'm going to do is I'm going to work on this upper number, and I would do 15 minus 1 times 0.012 squared divided by 5.629, which is chi-square from the left. And I want to take the square root of that and receive 0.018924727 as an upper number. And then I'll come over here and I will do 15 minus 1 times 0.012 squared divided by chi-square from the right, and then take the square root of that. 0.00878555103. And let me write that one down. So there's your confidence interval. And we have to round to the same number of places as the given sample standard deviation, which was 0.012. That's the rounding rule. And so we round to 3 places accurately. This one would be 0.009 less than sigma less than 0.019. Final answer for that question on the review sheet. 0.009 to 0.019. I could ask you for chi-square from the right and chi-square from the left separately as separate questions, and I could also ask you for the confidence interval width. That answer is C. C. Again, with this worksheet, answer 1 is C, answer 2 is D, answer 3 is A, answer 4 is C. Every single section is represented on this particular worksheet. There are no sample size questions with this worksheet, unfortunately. I hope that this practice test and this review sheet have helped you tremendously. If you need any further help or instruction, please come to office hours. Please attend tutoring. Practice, practice, practice. I cannot say it enough or stress it enough. Practice is the key to success. And there's no other way around it. You have to practice outside of class, and you have to clear up any confusion that you have by going to tutoring or coming to see me. Let me know if you need help. I will be more than happy to help you with the material here prior to the test. God bless you and have a wonderful day.